Hello again, my fellow students, and also anyone else watching this video. My objective today is to discuss functions, a very basic review of functions for those of you who need this review before we start getting into topics that are a bit more advanced, such as trigonometric concepts and the unit circle and all that. But first, you have to have a foundation, right? So the basics of a function are basically that it's like a machine. Right? So suppose you have a machine, you put in a number, multiplies it by 2, adds 3 to the product, and then outputs. The output is the result, right? So mathematically speaking, this machine is we call the machine a function because there is only one possible output from the machine for each input to the machine. So we can give this function a label. Typically, it looks like a scripted F. And I just told you that the function is accepts any number, multiplies it by 2, and adds 3 to the product. That sounds an awful lot like 2x plus 3. So the way you label a function, and I will now share my screen. Here we are. So this function would be labeled as f. Typically, it's like a scripted f of x is going to be equals, right, the equal sign, 2x plus 3. And typically, when you do a translation of it, you're still dealing with this should be familiar to you by now. All right, now, so the machine, the x part after the f on the left side indicates we're going to put x into the function f. So when speaking f, you should read that as f of x, by the way. So the x in the equation f of x equals 2x plus 3. That x is what we call a dummy variable, which means that it is really a placeholder, right? You're the one who's going to plug in whatever you need to plug in there. So you put a specific number in your machine, you replace the x. That sounds like evaluating an expression, which you should have done by now. So if you chose, let's say 5, right? So that would be 2 times 5 plus 3, and that equals 13, right? So when x is 5, you plug it into x. 2 times 5 is 10 by the order of operations, right? 10 plus 3 equals 13. That's the basic. Now, functions really are that simple. So you define the function, and then whenever you input a number to the function, you follow the definition to get the output. Usually, we use an equation to define a function for the obvious reason that f is the most commonly used label for functions. All right. So we're going to discuss in today's video only functions that take real number inputs. I can't stress that enough. I've consistently said over and over that you've got to be really careful with the type of numbers that you're dealing with. We are dealing with the set of real numbers. I'm going to do a video one of these days and talk about how so many common mathematical mistakes, I might actually do that tomorrow, are based on not understanding what set of numbers you are dealing with. So we're only talking about the real numbers here. Okay, functions take real number inputs and they give real number outputs. The domain of a function consists of all the values that you're able to input to the function and you get an output. And the range, you should have studied domain and range by now, of the function consists of all the values that can come out of the function. Right. So as an example of that, let's discuss a new function. Let's do f of x equals let's do 1 over x minus 3. All right. So here, the value, right, x, if you plug in 3 for x, you can't say that's part of the domain. right? Because you would have 1 divided by 0. You can't divide by 0, that's undefined. So we would say that this function is not defined when x equals 3. But you can safely put any other value of x into this function. So the domain, we would say the domain is all real numbers except 3. All real numbers except 3. In a similar vein, there is no value of x for which it is possible to make the function output 0. So however you can make the function output any other real number. So the range of f is all real numbers except 0. Like nothing else is going to work here, right? I mean, except those restrictions, everything else will work. So you call a function that can only output real numbers, obviously a real valued function, or even more simply, a real function. So unless a problem states otherwise, you can assume that all functions that at least the ones we deal with, are real functions, and probably in your algebra class as well, especially if you're in high school. You can also assume that they are only defined for real number inputs. So we're going to explore a variety of functions later on in my videos that can take non-real inputs and give non-real outputs, but we're not quite there yet. That's not the objective of this video. So you can sometimes use what we call interval notation to express the domain and the range of a function. For example, you can denote all real numbers greater than 3 and less than 5, right? You use the interval parentheses 3, 5 to indicate that the values 3 and 5 are not included. Notice I didn't say 5 and 3, right? I said the lesser end of the interval always comes first, right? So we write x is an element of 3 and 5 in the interval notation, right? To indicate that x is a number, right, in this interval. So, okay, x is in is how we read this. Okay? So if you want to include a boundary value in the interval, you can use the brackets, right? The brackets, of course, for the lower bound and the other bracket for the upper bound. For example, if I told you the statement, let's say x is in -3, put it up here because if I wrote this and I wrote parentheses -3, 5, but then notice I put a bracket there, right? That means -3 is less than x, and x is less than or equal to 5, okay? Likewise, if I did it the opposite way, like if I started with a bracket, or if I just use brackets rather, I would say y is an element, or y is in and then just use brackets, right? And I could use 3 and, well, I can use for the y's here -12, let's say, -12 and -12.2 and 0, let's say. You can use decimals too. All right, in that situation, right, that means -12.2 is less than or equal to y, and y is less than or equal to 0. If you want to indicate that an interval has no upper bound or no lower bound or neither, you use the infinity symbol, right? The infinity symbol looks like this. I'll write it on the left side here, right? That's infinity, okay? For example, if you write, let's say t was greater than -3, right? And if it would go on, that would mean it goes, you would have t is in, and then you could do parentheses -3 to infinity. And as you can see, the functions here are really operate like the machine. They're very well defined. So the -3, of course, that indicates that no numbers equal to -3 or lower than -3 are in the interval. Okay, and the infinity part, of course, that it goes forever in the positive direction. That is, there is no upper bound. So the interval is all real numbers greater than -3. Okay. So we always use we can also use negative infinity, by the way, if it was going in the other direction. So to write all real numbers in interval notation, you can write -infinity to infinity, right? That's how you do it. So you can often use the symbol, if you haven't already seen it. It's called the R for real numbers. It looks like an open R, like this, sort of. Okay. That means all real numbers. Okay, or you could just say X is in all real numbers, right? To indicate that. Okay. So let's do a very basic one, very basic equation. Let's say a function, not equation. Let's say f of x let's say it's equal to 2x squared minus 3. Okay, we want to evaluate that at f of 2. So you just plug it in. Anytime you see x, you're going to put in 2. So 2 parentheses 2 to the square minus 3. Well, that's 2 times 4, right? 2 squared, you should do that first, right? Order of operations. 2 times 4 is 8. And then you just subtract, right? Which would give you a final answer. 8 minus 3 is 5. Okay. Now, what if we asked you, okay, we're still looking for, we're still using this equation. What if I asked you find all values of t I'm going to put it up here again. Okay, so this time we want to find all values and let's impose such that f of t equals 47. This typical question you might get. Okay, well, if f of, excuse me, if f of t equals 47, that means you now have to plug in the t where you see x, right? Because we're evaluating at t. So that's what you're going to plug in. So now you have 2, instead of 2x squared minus 3, you have 2t squared minus 3. And we're saying that that's equal to 47. Okay, well, you know the drill. This is a basic equation. You add the 3 to both sides. You now have 2t squared equals 50. And if you divide, well, you can simplify. You divide by 2 on both sides. You're going to get t squared equals 25. Okay, and so the two values of t that satisfy this equation are t equals, we could say, well, plus or minus 5, right? T equals 5 and t equals -5. Now you can check your answer and see that it actually works out perfectly, right, if you plug it back in. So you can often check your answers in algebra by plugging the solutions, as you already know from solving equations. Same thing for functions. What about if I asked you to find, again, same function, 2x, the original function was 2x squared minus 3. What if I asked you to find, to evaluate it at 3x plus 1? Okay, and that was f of x. But now I want to evaluate it at f of 3x plus 1. Okay. Well, now this whole thing is what you have to plug into the x, right? So you can input an entire expression into a function, right, by replacing what we said earlier, the dummy variable, with the definition of the new expression. So you can replace x here with the expression, right? So now you have f of 3x plus 1 is now equal to 2 parentheses 3x plus 1 squared. And you keep, of course, the rest of the stuff. So now you need to evaluate this, right? So inside the parentheses, you've got 3x plus 1 squared. That means 3x squared, which is 3x times 3x, which is 9x squared. So now you have 2 parentheses, 9x squared plus, well, now it's 2 times the 3, so 6x, 3x, right, times 2 gives you 6x. And you, well, the 1 squared is just 1, right? So that's plus 1. Minus 3. This is why you should learn things like the distributive property and they should keep drilling that into you. Because otherwise, this, everything builds upon these foundations. So now you have outside the parentheses, you have a 2. 2 times 9x squared is going to yield 18x squared, right? So we have 18x squared . 2 times 6x is going to give you 12x. 2 times 1 is 2. But 2 minus 3, that you had that remainder there, is minus 1. You had that remaining constant. So this is now your new solved problem. Okay, a function can also be defined to accept multiple inputs, right? Multiple inputs. Why not? Let's use a new function. Okay, this time we're going to say g of a, b, and c and 3a minus, let's do 3a minus 2b and plus 7c squared. You can do that. All right. So the question then is, let's evaluate at three new points, right? So g of 3, -5, -1. Okay, well, you go in that order. That's the a represents 3, right? The b represents -5, it's a placeholder, and the c represents -1. So first plug them in and see what you get. Put a pause and see what you get. Okay, so you should be getting 26. 26, right? How? Well, let's do it. 3 times 3 minus 2 times negative 5 plus 7 times negative 1 squared. Right, that's your plugin. And that's 9 plus 10, right? And then you do the rest and you get 26. (19 plus 7, 26), right? Because negative 1 squared becomes 1, right? So positive 1 times 7, 7. Got to be really careful with exponents. Have to be really careful with exponents and the order of operations. All right, let's do another one. Now, I want you to find B. I want you to find B if G, oh, let's erase this. Okay, find B if, let's do G is B to a negative 1. Well, a lot of students, what they do is they start plugging in and they say, okay, so that's easy, right? They'll say 3 times 2 minus 2 times B plus 7 times negative 1. Right, so let's do that. Minus 2B plus 7 times negative 1 squared. They do all the calculation and then they say, okay, that's easy. Well, 6 minus 2B plus 7 times negative 1. So then they'll say negative 2B plus 13, right? Equals, right, 21. By the way, I forgot I should have mentioned, I should put here 21 in the original. And then they solve for B. And you should be getting negative 4. B equals negative 4. Is this correct? Is this correct? It's not. This is bogus. It is a bad solution. Okay, you have to see your mistake immediately. Check your answer. If you plug in G of negative 4, right, to a negative 1, that would give you a result of negative 9 in the original function, not 21. So you want to fix this. Okay? When you evaluate a function that accepts multiple inputs, make sure you assign the values to the dummy variables in the correct order. Let me repeat that. When you evaluate a function that accepts multiple inputs, make sure you assign the values to the dummy variables in the correct order. If you don't do it in the correct order, it's wrong. Unless you get lucky or something. But even if you did, you'd still be following you'd still be doing poor mathematics. We don't want that. I've had a lot of students tell me, but I still got it right. So, but you still got the math wrong. You're not following the math principles. So the way to replace this is you got to use B. Use B. Don't be afraid of variables. Don't be afraid of variables. So now let's rewrite this then. we now have 3b minus 2 times 2 plus 7 times negative 1 to the square. Okay, that yields, well, 3 times b is 3b, negative 2 times 2 is negative 4, plus 7 times negative 1, so that's going to give you minus minus, so that's going to give you 3b plus 3. We know we now need to have 3b plus 3 equals 21 to find the value of b. Well, that's easy, right? Now you just subtract, right? 3b plus 3, so you subtract on both sides the 3, and now you get b equals 6. Check your answer. Now you get what you desire. Just for the sake of room, I'm going to do a shortcut to show the work. You got 21, so you subtract 3 and divide by 3. This gives you 18 over 3, which is 6. Big difference. Big difference. Okay, let's do another one. Another function. Let's have t of x let's do ax to the 4th and let's do bx squared plus x plus 5. Okay, a and b are constants. Let's say a and b are constants. Okay, we want to find t of 4 if, let's impose the condition, t of negative 4 equals 3. I'd like you to try it first and then see what you come up with. So you can put a pause. All right, so we start by solving this problem by using our skills of substitution. So we have t of 4. We're going to plug in 4 every time we see x. So that's a to the 4th, a to the 4, right? A 4 to the 4th. A times 4 to the 4th. Plus b times 4 squared plus 4 plus 5. If we simplify this, 4 to the 4th should have given you 256. That's 256a. 4 squared is 16, so that's 16b. And then you've got your 9 here, right? Because 4 plus 5. So now you have 9. now you can find, if you can find A and B, you can then evaluate T of 4. So you turn to the only other piece of information you've got, which is T of negative 4. I told you that T of negative 4 is 3, is equal to 3. So let's evaluate that. We now have, if we substitute it, we will get 256A again. The only difference is that we would then get minus 4, right? Minus 4. So then we have our new expression. If you do the substitutions, I'm going to save you time, but your new expression is 256A plus 16B plus 1. So T of negative 4 equals 3 gives us this new expression, right? So this new expression is equal to 3. I hope you're following along. So that means that 256A plus 16B has to equal 2. Right? Because I subtracted the 1 on the other side just to make it easier. Unfortunately, though, this doesn't tell us A or B. However, you look back at your expression for T of 4. Look back at your expression for T of 4. You don't need A and B. You need 256A plus 16B, which we know equals 2. Right? We know that equals 2. So we have your expression now, your function becomes 256A plus 16B plus 9 equals the 2 plus 9, right? So 2 plus 9 is equal to 11, right? So keep your eye on the ball. Sometimes you don't need to evaluate every variable in a problem in order to solve the problem. And that's all I have time for right now, but I would like to do another video. Oh, I'm sorry, I realized I didn't share my screen. This was the solving here, what I did. This was I hope you're able to see it now. Right, so these are my substitutions. Right, this was the original. And then I just plugged it in. And I got this expression. And then when I plugged it in for negative 4, the only thing that changed was this 1 here, right? And that's equal to 3, because I told you in the original problem, right? T of negative 4 equals 3. So if this is T of negative 4, that's good. This is the expression for that. That equals 3. And then I simplified it. I moved the positive 1 to the other side, and I got 2. Right? I also said that in order to get, you don't need to find A and B, because the original expression, the 256A plus 16B plus 9, right? We know that that equals 2. Right? And that's how we were able to solve this. I don't have more time in this video to do more, but I would like to do another subsequent video talking about the domain and the range of a function, and then also discuss in another video the common errors that students often make when they are evaluating expressions and when they're dealing with numbers, and they make certain false assumptions. A lot of what you've been told in a mechanistic way. And if you learn things in a mechanistic way, you're not actually doing math, because you're not asking the why. You need to ask the why. If you don't ask why, you're not really understanding the procedures. All right, well, thanks for watching.